Back? Okay. So now that we've gotten over all the Docker stuff, let's go ahead and chat about SQL. So Mark, you had a question?
Yeah, since Postgres is such a stable, long-running software, what kind of things would change between versions? Like, I'm assuming SQL is not going to change the language, but
Yep.
what types of features would they be changing?
Cool. So yeah, like what's changing from version to version on Postgres? Super valid question. So the first thing to know about SQL and Postgres are kind of different things. SQL is a standardized language that exists across not just Postgres, but it also applies to SQL Server, Oracle database, IBM DB2, MySQL, MariaDB. There's a bunch of databases that all use SQL, and there's one single standard language. You can kind of think of it like JavaScript, right? JavaScript is a language, but there's different runtimes that run JavaScript. There's Node.js, there's the browser, there's Deno, there's now Bun, there's Rhino, there's JerryScript, right? They're all using JavaScript, which is the name of a written language, but something different is executing them. It is the same thing with SQL and Postgres. The interesting thing about SQL and Postgres and all these different permutations is they all kind of have their own flavor. Despite the fact that SQL is a standardized language, they all take their own different approaches to it, and they all add their own features to it. So a great example of this is we're going to talk about down in quite a few lessons. There's one here called like JSON-B. This is not a part of the SQL spec. This is a Postgres only thing. So that's what changes between versions, is they're adding all these cool new features that are specific to Postgres, and they're making refinements and they're trying new things. Like once we get to JSON-B, you're going to see like, why wasn't I teaching this the entire time? Kind of spoiler alerts right there. But that's what's changing, is they're adding new cool features, and they're still innovating at a pretty rapid pace. And particularly Postgres I feel like is leading the pack, which is why I chose to teach this one over MySQL mostly. Does that answer your question? Yeah, I don't know what's changing in 15 if that's but I'm sure they're adding cool new stuff as well.
So is it probably like around like sharding and these type of things, or is it?
It'll be, I mean, all of the above. They'll add new operations techniques, and they'll add new features to actually things you can do with SQL. Yep. Cool. So now's as good a time as any to address the SQL, SQL elephant in the room. What is the correct pronunciation of SQL? Well, it depends on who you ask. I did a decent amount of research of this because I was positive that someone was going to ask me. The correct pronunciation of SQL, according to the body that defines SQL, is SQL. They pronounce it SQL. However, the people that make SQL Server, aka Microsoft, calls it SQL Server, right? One of the most well-known people that works on defining what SQL is and writes all these books about it, she calls it SQL. So in other words, SQL is probably, by the most definition of that, the defining body calls it SQL is probably the most correct, but SQL is equally valid. I call it SQL because that's just what I've always called it. There are other people that will always call it SQL. But I think generally my rule of thumb is if I'm talking about MySQL or Postgres or one of those, I generally say SQL. And if I'm talking specifically about SQL Server and Microsoft Stack, I will call it SQL because that's what everyone in that community calls it. Basically, Microsoft and Oracle have codified SQL. So if you're talking about Oracle as well, they call it SQL in their docs. Basically, everyone else that I'm aware of calls it SQL in terms of like it's PostgreSQL, MySQL, MariaDB calls it SQL. So they're both correct. Someone will get really opinionated about it, and you can just tell them that you don't care because it does not matter. We're both talking about the same thing. There's a really interesting history about it, but suffice to say that SQL was invented in the 70s. It was derived from a language called Square. They tried to call it actually literally SQL, S-E-Q-U-E-L. That was some acronym. That was the name of some fighter jet or something like that, so they couldn't call it that, so they ended up calling it Structured Query Language, SQL, and we ended up with that. A fun fact is that my dad actually used to work on SQL databases. He worked on DB2, which is the IBM flavor of it. They still sell DB2 these days. And then he ended up being a technical salesman for IBM for years and years and years. So this is actually stuff I ended up growing up around, kind of unintentionally. It's really funny to my dad that he did all this stuff for all these years, and now I'm teaching it to people. So, fun fact. Hi, Dad. He might be watching. I don't know. Hope I make you proud, Dad. Okay, so let's get into structured query language, SQL. And again, you can call whatever you want. I will never correct you because I profoundly do not care how you pronounce it. And it's one of those things, those hills that people choose to die on for no apparent reason. So we are going to get started on tables, not inserts. So if you're not already, please get to running inside of your container. You should see something here like Postgres, like that. If not, you can go back to the previous lesson. It will show you how to do that. And let's start running some commands. Okay. So again, we are interacting with the Postgres database with a client called PSQL. Those are different things, right? One is a database, one is a client that is sending queries and getting information back. So I could be hosting one database and everybody else could be querying it with their own PSQLs, right? So you have one database, but you could have many clients to it. This client has a bunch of built-in kind of helpful commands, and if you forget what they are, you can hit \\. And this will just pop up a really helpful sort of help information that'll show you a bunch of stuff. I use it all the time because I can never remember all of them, but there's a bunch of stuff here. You can run commands out here. So if I do \!, that'll allow me to run a bash command and the underlying bash. Sometimes that can be helpful. You can like cat in files and things like that. We're not going to be using that today, but there's a bunch of stuff you can do with it. And anything that you see prefixed with a \\, that's going to be a feature specifically of PSQL and not necessarily of Postgres, the database. The one that I find myself using a lot is \l. This will show me all of the databases that exist. And I'll use \d quite a bit. We haven't created any tables yet, so it will not find any. But \d will show you all of the tables and sequences and constraints and stuff like that. So that's a good place to get started from there. So we have a bunch of default databases. You can see here I have Postgres, I have template 0, and I have template 1. So the first thing to say is, what is a database? Aren't we connected to a database? It's a bit of a conflated term. In this particular context, when I say we're connected to the Postgres database, it means I have my Postgres server running, and there are multiple databases inside of this. You can think of a database in this context as a folder, right? It's a folder that contains many tables, right? Which you can kind of think of like spreadsheets, right? So Postgres here, or template 0, template 1 would be the name of my folder that I'm in. In a moment, we're going to create our own database or create our own folder, but a database contains many other tables and things like that. Okay? As you can see here, your database comes with 3 of them pre-created. Okay? So the Postgres one exists solely as the purpose, as it's the default database that you connect to. If you don't give it anything that is like you're trying to connect to a specific database, it just exists for that purpose. It's the default one. You can technically delete it. There's no reason that you can't delete it. You also don't have to. That's up to you. So template 1 and template 0 exist for the fact if you are creating and deleting a bunch of databases and you want to have like a templates to start from, you would use template 1. You would make a bunch of modifications to template 1, and that'll affect the default database that you create. If that gets all out of whack, what you'll do is that you'll then clone a new template 1 from template 0. You should never modify template 0. And this is basically all stuff that you can totally forget because I never use them. This is why they're there. This is why they exist. But I never use the templates. I always just create everything from scratch because I don't find myself creating and deleting a lot of databases, right? I generally just create my database and then just go from there, right? So, but I wanted to know why they're there. Okay, that being said, we are going to run this command, right? So I'm going to say create database recipe guru. So a couple of things to note here. Now I can say \L, and you can see here we have our recipe guru database. So we've created our own folder to work from. We're going to be doing the first part of this workshop. We're going to be creating a recipe website. Okay. Hence the name Recipe Guru. Now you might have seen there that I said in all caps here, create database like that. Why did I do it that way? Why is it all caps? Well, the reason why I do that is so that you can see the commands that are coming from SQL are always going to be in all caps when I do them for you, and everything that we do that's like optional user-controlled information, that's going to be in lowercase here, like Recipe Guru. That's a very common pattern in SQL, but there are also people that insist that you should never do caps, and it's really dumb, and people are wasting their time and pinky strength by holding shift down for so long. And again, it doesn't matter. I like it. Whenever I'm writing code, I tend to do everything in all caps, so it's really easy for me to glance at and say, like, okay, create database, that's a command, Recipe Guru, that's the name of the database, and it's really easy to parse that visually. But there's no requirement that you have to do that way. I will find myself when I'm just writing queries, just to like write queries, I'll probably not do caps just because I'm lazy, right? So that is totally up to you, and it's one of those things like SQL versus SQL, it really just doesn't matter. So it's never worth getting into an argument with anyone over it. Okay. So I'm just going to throw out here one more note that if you kill your container at this point and you restart the container, you will have to recreate Recipe Guru again because it's going to give you another blank slate, right? That's just another word of caution that I'm putting out there. I do provide here this complete SQL file. You can actually download this. This will actually be the complete Recipe Guru. So this will give you actually the first half of the workshop already done, if you need that. Or you can use the container from Docker Hub, which is the this one here, the complete intro to SQL. And that will also give you the complete Recipe Guru database. Okay. So a database is a collection of similar tables. For all of our recipe apps, we'll be storing them in one database. People ask me frequently, when do I use multiple databases? When do I just shove everything into one database? That is a very you call to make. In general, I tend to shove a lot of things into the same database because I don't really see the use in trying to, make them work across databases. In particular, if anything would ever have to be like related to something else, like I have my ingredients, I have my recipes, those obviously have to be connected to each other, right? Those have to be in the same database, no matter what. But let's say I have like user session information and I have recipes and ingredients. In theory, those could live in different databases because I would never have to like collate those two together, right? So it's a highly opinionated thing, right? It's kind of like asking the question, should I have two services or should I have one monolithic service, right? Should I have microservices or macro services? It depends on what you're doing. For your purposes, getting started, just throw everything in a database and in general you'll be fine. The question you can kind of ask yourself is, would I ever have to scale these things independently? Which is where it can be useful to be split across databases. Okay. So you can see here I created the Recipe Guru database, but I am still connected to the Postgres database. So I want to switch my connection. So I'm going to hit \C recipe, and then this actually does have tab completion. So I can hit \C recipe guru, and now you can see here I'm connected to the Recipe Guru database, which again has nothing in it. If you put \D, you will not find any relations yet. But we're going to go into the next lesson. We'll actually create some tables. Any questions? All right. Killing it. So let's create our first table. We're going to be creating an ingredients table. So you can see here, let's just run it, and then we'll talk about it. So you can just copy this, or we can even just type it out a little bit so you can actually kind of get a feel of what it feels like to type it. Create table, ingredients, and it's going to have a couple of things in here. So we're going to have an ID, which is going to be an integer, or you can put integer like this, or you can just put int, it's the same thing, or int4. I don't know why that would ever be the one that you would choose, but you can choose that. Int, it is a primary key. It's generated always as identity. Okay, then we're going to have a title. It's going to be a varchar, and we're going to give it a length of 255. It is unique and not null. Okay, then we're going to close our parentheses, and we're going to hit a semicolon. So first of all, the way that we know that it successfully ran is you see here it says create table. It's going to repeat back to you what you just did to tell you this worked, right? And now if I hit \D, you can see here I have a table and a sequence, which is what I'm expecting. And if I say \D on ingredients, it'll actually describe the table to me, which is an integer, of ID, and a title. So all this works. Let's actually break it down piece by piece of what we actually just did. Okay. So create table. We're telling SQL we would like you to create a new table. You can think of a table as basically just a spreadsheet, right? It's got rows and it's got columns. The columns are all represented here like ID and title, right? It's going to have an ID for every single one of these, which is basically just a unique identifier, right? That's literally what it is. And then we're going to have a title, which is going to be something like cucumber or flower or chocolate or whatever you want to think of there, okay? We're naming the table ingredients, and then we're going to give it all of the various different columns, right? You can basically think of, like, again, setting all of the column names in your spreadsheet. You have to tell it what type of thing it is. We're telling it the type of thing, the data type here is integer, so this can only be a number. If I try and put, you know, Apple into the ID, it's going to say this is not an integer, you can't do that. So it actually is going to verify and make sure that that's true. We're going to say that this is the primary key. Every table that you're going to create is going to have some sort of primary key, right? It's going to say like, this is how I'm going to index this table, right? So in this case, we're just saying that the ID is the primary key. That's going to be very common. It's not always true. I'll show you one later in the course that's not. But for now, most of these are going to be IDs kind of like this. And then this generated always as identity. If you've done previous versions of Postgres, they used to call this serial, S-E-R-I-A-L, right? Not the food. They actually, I think you actually still can do it. I think it still works, but it's been, if it's not been deprecated, it's at least been de-emphasized. This is actually more compliant to the SQL spec. That's why this is preferred now, even though serial was a bit more simple, right? But here we're saying basically, we want you to always generate this key for me, and I want it to be incrementing, right? So the first thing I'm going to create is going to be ID 1. The second thing I create is going to be ID 2. If I delete that one and then I recreate it, the next thing we'll create will probably be ID 3, right? So it's going to give everything across your entire app a unique identifying key that we don't have to keep track of. That's what this ingredients ID seek, this thing right here, that's what this actually keeps track of right here, is it's the next thing in the sequence, right? The next number that's going to be put into that ID, okay? So that is the first column. The second column, we're saying that we're creating a title, right? The varchar is a type of string, right? So text, right? Free text. And we're saying that this has a max length of 255 characters, right? So if you have a ingredient that's 256 characters, it's going to truncate the end of it, and it's not going to store that last one. We could put another one here called text. So it would just be title, text, unique, not null, right? Text is infinite length, right? It's variable length. But titles in general, like the title of your ingredient's not going to be very long. This allows Postgres to kind of shrink that storage size a little bit, right? Keep it a bit smaller. And then the length is 255. That's a common one to pick just because that'll fit in some amount of bytes. I can't remember exactly how many, but it's pretty reasonable that we can expect the titles of our ingredients to be under 255 characters in length. And that is our first table. It's an empty table, but nonetheless, it is a table. So we've created our spreadsheet and we've put nothing into it. But we now have a place to put data. You're going to hear me a lot today use the spreadsheet analogy. It's because databases, well, basically a spreadsheet is a database. It's just a database that it's really easy to edit with Google Sheets or Excel, right? And it's not actually theoretical. You can actually use Google Sheets as a real database. You can write SQL queries that work against spreadsheets. So it's not theoretical, it's actually a true thing that you can do. I'm not going to recommend that you run your entire company on Google Sheets, though I've heard of people doing it. So, okay. So we're going to talk about inserts more in the next chapter, but I want you to just copy and paste this bad boy with me, the insert into ingredients here. Mostly so that we can see what happened. So I inserted into ingredients, I inserted a bell pepper. So now if I say select star from ingredients, you can see there I have one thing in my database. I have a bell pepper. But notice here at nowhere did I specify the ID, right? The ID just came with it. This is what I was saying about this primary key generated always as identity. That's where that comes from, right? So it's going to just keep updating that. So you don't have to keep track of it. The database keeps track of it for you. Cool. And again, we'll talk about inserts in depth in the next chapter. I just wanted you to, as well as selects in the chapter after that. But I wanted you to see this is how stuff makes it into the table, and now we actually have something in our table. Yep, so they used to call it serial like that, but now the generated always identity is more compliant to the generic SQL one, and they're trying to be good citizens of the SQL world, so that's where generated always as always comes from. Okay. And so you should see something like that, which you saw. So I want to show you how to drop a table. So let's do that just for fun. Drop table ingredients. And now if I say \d, you'll notice that it did not find any relations. That's what drop table does. By the same token, you can say drop database, recipe guru. We could totally do that. I'm not well, whatever, let's just do it. It's fun. Except you don't have to do this, but... And then now we can drop database recipe guru, and lo and behold, it is gone. So create database recipe guru. Cool. A note on semicolons. A semicolon means the end of a statement. Just like in JavaScript where you put like a semicolon at the end of a line to let JavaScript know period, full stop, end of sentence. It's the same thing in Postgres. It is required here though. There's no automatic comma insertion in Postgres. It's going to keep going until you give it a semicolon to let it know that I'm finished with this. So it does mean that you can put multiple statements on one line, right? Multiple queries. I'm going to use those terms more or less interchangeably, statements and queries. The one thing that you notice here when I do this like \c recipe guru, I'm not putting a semicolon there. It's because PSQL doesn't care, right? Because this is, excuse me, this is not SQL. This is PSQL helper things, right? So it doesn't care about semicolons, but your SQL does. That's why sometimes you'll see it and sometimes you won't. Make sense? Okay. So let's create our table again. I'm just going to copy and paste it this time. And let's now change a table. Sometimes you'll have to do this, right? So I'm going to say alter table ingredients. And we're going to add a column. Okay, and then we're going to add a column of like an image, right? Because we're going to want all of our ingredients to have some like representative image. So I'm going to say add column image, and we're just going to make it another varchar of 255. Because for the most part, URLs are not longer than 255 characters. In our case, they definitely won't be. So alter table, you give it the table that you want to change. You tell it what you want to do. You can also drop columns. You can change columns, right, from one data type to another. These are all things you can do with an alter table statement. Okay, so now if I say recipe guru, not recipe guru, it's ingredients. You can see here it now has an image. By the same token, we can alter table, ingredients, drop column, image. And now if we do that again, you can see here we had an image up here, and we no longer have an image down here. Yeah?
If you had kept the table with the data in it and tried to add a not null column, could you do that, or you run into errors?
So the question is if I have a not null constraint, we are going to talk about constraints. You can see here that it says nullable, not null. And if I try and add something that has a not null, what happens? You have to tell it what to do. So I actually don't have anything in that like that in here, but if you just tried to do it and didn't do anything, it would error, right? Because it's like you're trying to do something, these all don't have anything to do. So in general, you're going to give it some sort of default value. Or you can give it specifically like, okay, for all of these columns, give this one, this one, this one, this one, this. But you have to provide for that kind of thing. The easiest thing to just say is like, give all of them empty string or something like that, and then go back and change it. But does that answer your question?
Totally, yeah.
Cool, good question. Yeah, Dustin.
Can we add a column that stores image content?
Can we add a column that stores image content? So I believe the question is like, can I read out the binary data, like actually dump the actual image, not just like a path to the image, but the actual image, and then store that in Postgres? You absolutely can. I'm going to say that 99.999% of the time that is a horrible idea, and you should absolutely not do that. but it is possible. There is a binary data type that will store something like that. Postgres is not really made, it's made for fast querying and retrieving of information, and you're not going to query by binary data, so storing it there doesn't make a ton of sense. When there's something like, I don't know, Cloudflare or something like that that's much better at storing images and handling images. But if it really is like you're just putting some stuff in there because later you want to get them out, sure, that it does technically fit in there. Any other questions? Cool. Well,
We're gonna do a quick tech break.
can I have 5 more minutes? Or no? Okay.
We have 5 minutes. Can we do, or can you go for 5 minutes?
No? Okay. We'll take a quick tech break. We'll come back in like 5 minutes, and then we will keep going.